I will continue to record. Okay, there is reason why I split the recording so that if there is anything problem, we not lose the entire session. So that's why I split. Okay, let's say my recording, if both successful, okay. If if there is internet problem, at least I can save either one of the session. Okay, that's why I split recording. Okay, so now I'm start recording again. So now we are waiting for Zian Huai and Hanisa to share the answer. Okay. I think I have a problem with my mobile data. I'm not using mobile data, but my handphone now problem. So I don't know if I hope my Wi-Fi is still okay. Okay, so we are waiting for Hanisa and Zian Huai. If you get it wrong, no worry. That's why we are here. Hanisa okay ke? Hanisa, do you manage to get it?
Sekejap.
Tak tahu betul ke tak ke?
Tidak
Share,
eh.
share je.
Okay.
Don't worry if you make it wrong. Just share because I will able to say, oh, this is wrong. Then we learn from each other. Doctor, I try to solve it. Can I share myself? Yes, mana? Yes, share it. Why not? Okay. Because only by answering my question, then I can only by sharing your answer, then I can say I can check whether you make mistake or not. It's better to make mistake now than to make mistake in the exam or quiz. Okay, you can please share. Okay, in the Telegram. Murad also, if you want. Okay, so the noise generated in amplifier of 5 megahertz bandwidth, so we have B already there, and then it mentioned noise generated in, means that it is a NE. Okay, so 0.082. Now calculate noise factor and noise figure if the amplifier was fed with source input signal and temperature 300K. Means we don't know our I. Okay. Okay.
Doctor,
Huh?
I didn't solve for noise factor.
Noise factor?
I didn't solve for noise factor because I don't know how to calculate TI.
Noise factor or noise figure? Because noise figure is just log of noise factor actually.
Really?
Yeah. So noise figure is correct 6.9, but noise factor is just anti-log lah. Anti-lock tahu kan anti-lock kan?
Hmm, noise figure tu dah betul lah. 6.9.
Yes, that is noise figure.
Okay, lepas tu
Uh,
noise vector.
noise
How to
vector,
do it?
noise figure is actually 10 log of noise vector. Faham tak?
Oh, okay.
So divide by 10, lepas tu anti-log lah.
Okay.
Uh,
How to do that?
okay, cuba delete balik tak letak balik. Okay, delete balik, delete your own answer and try to re-upload lah.
Okay.
Okay, so I'm sharing the screen. We learn from Mana first, okay? And the rest, you please share if you want for us to, to check your answer. Okay, for me lah, not for us. For me. Okay, do you see the screen? Okay, I think you can see. Okay, so this is Mana. Okay, even if we make mistake, no worry. That's why we are here. We are here to learn from mistake. From our friend's mistake. If our friend didn't make mistake, maybe we don't know what we don't know. Okay, so first Mana, she calculate the input noise, which is how to wait. I wait for this to actually go up. Oh, okay. Now it's finally go up. So the screen becomes slow because we are doing recording. So Ni equals to KTIB. So this is good. Means Mana put a TI here, because if she didn't put TE, TI, then it's become confusing. Okay. So it's good here. Ni equals to KTIB. So 1.38 times 10, this is a Boltzmann constant. And then the temperature, okay, 300 Kelvin, 300 K. So maybe no need to put K here, Mana. Depends on you, but hopefully you don't confuse. Otherwise, you accidentally press your calculator. 300K means 300,000. Okay? Understand, Mana? Just thumbs up if you understand. Okay? And then you have bandwidth. Bandwidth given as how much is the bandwidth? 5 megahertz. Means is 5 times 10 to the power of 6. Okay. So the answer is 0.02 picowatt. So it's correct. Okay. So it's actually small. Noise is doesn't have if you find noise a big number, then it's illogical. Illogical. Because noise, right, is something that we are not intended for it to happen. It will happen naturally. If it happen naturally, normally it is not too big as compared to the real signal. So this one is logic lah, this value. And then after that you need to calculate. Okay. Mic problem. Later I go to you. Okay. So okay, then I later go. And then we have the F. Okay. Have F, which is the noise factor. So noise factor is 1 over NE plus NI. So this one is correct. Okay, if you see from the equation, okay, I'm showing you. If you want to do the noise factor, not noise figure, factor. Factor means not the log, not the log. So Mana is using this. Okay, F equals to 1 plus NE over NI. NE is the noise the amplifier, okay, being taken out, and this one is the Ni, okay, Ni, the input noise. Okay, so I take it back. So Mana answer is correct. Okay, the answer, the real answer, not the real answer, I mean the answer is 4.9. Okay, which Mana correct. Okay, correct. She did the rounding. So it's correct. 5. And after that, the noise figure is actually just a log of this. Okay, so it's 10 log 10 5, so get 7 dB. So it's correct. So this one is answer correct because it doesn't have unit. Okay, if you guys have unit for noise factor, for example, you put kilo, megahertz, whatever, it's wrong because it is a ratio. A ratio, we don't have unit because here, if you even if you put unit, what over what means cancel out what means you only have number. You should only have number here. And this one, because it is not a ratio, it should have a unit in terms of what? And because noise figure is a logarithmic, so you should have dB. Okay, but you don't have unit, but you have dB. Okay, because it's decibel. Then we see for Hanisa. Okay, this is the noise figure. She gets 6.9. Mana noise figure? Mana noise factor?
Yang tu yang lama punya, yang baru nak bagi.
Belum lagi.
Tak, ya
Okay.
betul.
Okay. So Gen 5, okay, 0. So she F, okay, figure, factor. So 1 plus like this. So this is also correct and without unit because it's a ratio. So there is one is correct. And after that noise figure. So okay, then why forget to put decibel? So it is wrong. Okay, and understand that Zen Y, this one should have dB decibel. Okay. Or this one, okay. I will give the answer for the B. You will try at home. I mean, you can test yourself at home. B, answer for B. I mean, you can test yourself at home lah. The B, just give the final answer for the B. Because if you get that correct, means the entire thing is correct lah. For the noise and F, wait wait, I'm type first slow the screen. Then F 11.04 B. This one is for decibel. This one is for B kot. Okay. So this one is B lah for the noise figure. Okay. Anissa have shared her thing. Okay. So so it's correct lah, 4.9. So if we run out, it will become 5. Okay, correct. Okay, correct. Okay, good. So we learn from our mistake is good. Okay, then we go to the next one. Okay, so this is the answer lah. Okay, no need to, nothing special. Okay, then an antenna is connected to amplifier with temperature TE, gain given bandwidth, output receive. Okay, this one is a bit challenging. Okay, wait I want to see if we have time to cover it. Yes, we have the time. Okay, so okay, you want to try this or you want to know the answer? Because you want which one? Can you tell me in the Webex chat? You want to try this at home or what? Maybe you try this at home. Is it okay? I will give you the answer. Okay, wait, unshare the screen first because I want to type. Unshare the screen first. So I give you the answer. You try at home. Okay, I put in Telegram. Okay. Exercise 4. The answer. What is? Wait, determine the antenna. Determine the antenna temperature. Okay, this one. Exercise 4. You try this at home because it's good. Sometimes you try at home means you will refresh your mind. You refresh your mind, you try at home. Don't try it now so that you have something to bring back home. Determine the antenna temperature. So 600 Kelvin. And then noise factor 1.2. Okay, so I already give the answer inside our Telegram. Okay, you try at home yourself for exercise 4. Okay. Okay, I share again the screen. Okay. Next is we do cascading. So this one is a bit difficult. It's not that a bit difficult, it's a bit challenging to explain online. Okay, never mind. I try my best. Okay, disappointed. Okay, so you will have commonly, we will not test you on the basic amplifier. Normally, we will cascade. Cascade means it will be connected to more than one amplifier. Means you will have at least two amplifier. So when we say cascaded, you will have several parts, okay, being connected together. Okay. Okay. So here in communication system, cascaded connection is common, very common. Below is an example of a cascaded connection.
Doktor,
Yes.
doktor tak share screen.
Tak share ke?
Uh-uh.
Aduh, hai. Sorry. Doctor screen tak share. Okay. Uh, Syuk sendiri je saya cakap dia. Okay. So normally in communication we will have connection not involving one component. Normally we will cascade. It is a combination of at least two or three components. So in communication system, cascaded connection is common, very common. So below is an example of cascaded connection. So this one is, if you see, if we have a antenna at the front here, so can you guys answer me, is this a transmitter or receiver part? You answer me at the telegram, at the Webex chat. This system, is it transmitter or receiver side? If we have antenna here at the beginning, is it transmitter or receiver? Oh, majority say what, transmitter? Okay, this is actually receiver. Okay. This is actually receiver. Remember I told you, when we have a transmitter, it's going to transmit. Means that when it is transmit, the final part will be antenna, transmitter. But receiver part is it going to receive. So the one that need to do the receiving is the antenna. So this one is actually receiver part. Understand? This one is receiver part because the first one that need to do the job is the antenna to receive the signal. So this is your antenna. So this one is actually a receiver. Okay, receiver part. Okay, the antenna to convert from electromagnetic signal to electrical signal. So antenna function as a transducer actually. In receiver, it acts as converter from electromagnetic to to electrical signal. Okay, so we have you see here we have input signal, okay, which is signal that we receive. The modulated signal. You will learn about modulation in the later chapter, section 2, chapter 2. And after that, NI, it comes with some additional noise. And we have a noise temperature as well. Okay. Then is go here for the pre-amplifier. So signal sometimes weak, we need to pre-amplify first. Sometimes it's too small. Okay, we need to amplify. For example, if I send 10 watt, maybe at the receiver I only receive 0.1 watt. So very small. After it travel few distances with noise and that and whatever, it got the value is attenuated and disturbed. The value is attenuated first. Second is distorted. What is distorted? Due to noise. Okay. So we have pre-amplifier to amplify, and because every of the component, as we learned earlier, have noise. So every of these component have their own noise. So here is the noise coming from the amplifier. We take it out just now, right? What we learned, right? We take it out, NE1, and this one is the noise inside the demodulator. We take it out, so it become NE2. Okay. And this amplifier have its own noise, so we take it out. So NE3 is for easy calculation. So if we don't take it out, it's actually, for example, say for amplifier, not pre-amplifier, NA. So NA equals Okay, this one is the one that we take it out. Okay, so let's say we don't take it out, it will become NA inside here. Okay, so it will be NA equals to G1 and E1. Okay, sorry. It becomes G equals to N E1. Okay, so the same goes for here. We take it down, we take it down. Okay, and then you can see this is actually the output signal and output noise. Okay, this is the gain of the amplifier G3, and this is the gain that exists inside our demodulator. Okay, I think pretty much the rest you understand. The notation. T1 is actually the temperature. Okay, the temperature we take it out. This one is temperature, we take it out. This is temperature, we take it out. Okay. So normally it's this kind of question that we will get cascaded. Okay. Okay, so the first level just now, the receiver part. Okay, first level is until the first pre-amplifier. Pre-amplifier. So if you notice, this is the signal. Okay, S1 equals to G1 S1. Okay, you see here S1 equals to G1 S1. Okay, this one is the signal that we after going through amplifier, and this one is the gain of the amplifier, and this one is the signal that we receive at the antenna. So S1 equals to G1 S1. Okay, S1 here is actually referring to here. Okay, and then the noise. Okay, the noise here N1. Okay, the noise after the amplifier. So we know, right, the noise is actually coming from the amplifier itself, and the one that we're having as input. Okay, so that's why this one you see just now, this one I told you, this one is take it out, and we have an I, and they are together are being amplified by a gain value of G1. Okay? And this one is just extend. You just extend KTIB, KT1B, then you factorize, then you get the value. Look a bit difficult, right? Not difficult, tedious or whatever, but when you understand, it's actually just expansion. Okay, just expansion of the whatever terms. Okay, and then it will go to the next amplifier, which is level 2. This one level 2. So it will go to the demodulator. Okay, demodulator. If you see in demodulator, you have S2, okay, as the output of our demodulator, and it is amplified by a factor of G2 of our S1. So G1, G2, S1. S1 you get is actually this value. Okay, so you just expand. Okay, actually it is pretty much direct lah. Direct, even though it's long, but it's pretty much direct. Okay, the same go for N2 as well. Okay, N2 is actually the noise the noise factor of G2 times our N1. Okay, what is our N1? You get it from here. Okay? So you just expand, and expand. The same go for level 3. Okay, the same goes for level 3. So it becomes this complicated, but don't worry, it's actually pretty much understandable. You just expand. Okay, you just do it carefully, as sometimes if you do fast, also not that good, because you will become too fast that you make mistake. So this one, if you do with slow, also okay, as long as it's correct, because it's just expansion, direct. This one is very direct. Okay, and then from that complicated system just now, means the one that we have cascaded, we cascade 3 parts from the antenna, then we cascade pre-amplifier, then we have demodulator, then we have I think this is what another amplifier, so it's 3. Okay, so that's why then also the F total. Okay, total factor. Okay, total factor. So SNRI over SNR input. So SI and I over SO and O. Okay. So for this one, SI and I is just NI KTIB. The tricky part, not the really tricky, it's just long. This one is SO and O, the one that you already explained just now. You just put below. Then you do simplification. Then you get this equation. Then you simplify further. Then you get actually this one. If the system, for example, if the system involve component having 4 gain, I mean component with 4 gain value, I mean 4 value of gain, so you will stop until G3. But for example, if our system here only have 3 three component with 3 gain value, so that's why you stop at G1, G2. So it's actually if we go to the general term, okay, the general term which is this, okay. So F total F1 F2 minus 1 over G, F3 minus 1, G1 G2. We stop at here because we only have component having 3 value of this gain, only 3 component having that value. So that's why we F total. Okay, this one is factor. Then you can do the noise figure you on lah. Noise figure you on. You can lock Sorry. This one, okay, sorry this one is actually noise figure. It is in decibel. This one is in decibel. And this one is also noise figure. Okay, is in decibel. Okay. So when you sometimes the question they make you, they trick you a bit or twisted a bit. We give the value in linear. For example, we give the value in, for example, we give 0.3 for example linear. Then you need to convert into decibel, all of them, because this formula is only using decibel. Understand? Need to convert to decibel. Wait for a while. This formula works in linear value example. F loss again are normally given in dB. Need to convert to linear first. Linear passive device have loss. Okay. I think it will be more clear if we go to the example. Okay. This is figure, then we need to convert to dB later on. Okay. So it's okay. We go to this example first. Easy lah. Okay, we go to the example. Do you have this solution with you here? Do you have this solution or you don't have inside the slide? I take it out or not? Do you have this solution for example 5? Yes or no? Can you respond me in Webex? Do you have this?
No, doctor.
Oh, okay. No, good. Okay. So, 3 amplifier ABC was connected in series. Noise figure and power gain of the amplifier given by this. Okay, noise figure. You see here, noise figure, dB, and power gain of amplifier are given below. Okay, they give lah. An input signal of 50 dB higher than noise level was fed at the input of the network. Okay, calculate total noise factor. Okay, calculate total noise factor. So if we learn from our freeze formula, okay, just now, F equals to F1 plus, because it's only 3-stage amplifier, so we only calculate gain of 2 value only, which is GA and GB. So F2 minus 1 over gain A plus 3 minus 1 over GA GB. Okay, I don't know why is my laptop becomes slower. It's my okay. It's okay. Then F1 is what? Okay, this one. Okay. Now I able to because we learn more sometimes more from the example. Okay, you see here. This one is F1. Means this is referring to this one. Referring to this one. So we need to change it to linear first. Okay, we need to change it to linear first. So F1 is 10, 3 over 10. Do you know how I get this value? Okay, example this one, this one is in dB. So 3 equals to 10 log answer, linear. So in order to get the x, is actually 90 log of 3 over 10. Okay, 3 over 10. So you can press calculator. What is the value? 10 to power 0.3. What is the value? Can you put? Can you show in the WebEx what is 10 to power 3 over 10? Means 10 to power of 0.3. What is the value? Okay, you calculate first while I'm doing this. And then F2 is this one. So 10 to power of 5 over 10 minus 1 over the gain of B. Gain also we need to convert to linear. Okay? Which is this. So 10 convert to linear, 10 20 divided by 10. That's why we will have 2 lah. Okay, and then plus this one, plus this one which is FC 10 over 10 minus 1. Okay, and then it consider until gain this one. Okay, GAGB. So 10 to the power of 20 over 10 times 10 to the power of 10 over 10. What is the first value? 1.99. Second value? This one? This one? What is the value? 10 to the power of 5 over 10 minus 1 over 10 to the power of 2. The second value, what is that? Minus 1, 10 to the power of 5, 10. Sorry if it's not clear, I write it more clear here. Something like this. Because my laptop is slow because I'm recording. Okay, 0.0, okay, 0.0216, 0.0216. Okay, the third value? 0.09, 0.009. Okay, so the total value is what? The total. So 2.0206. So this one is actually linear value. Okay. Remember, the question asks to find the noise figure. Okay, never mind. They say total noise factor. Okay, so this is correct already. But we want the answer to be in noise figure. So 10 log something. Okay, so noise figure. What is the log? 10 log of this number. What you get? 10 log 2.0206. What is the value? Okay, so the answer is 3.05. Okay. Okay, I try to, what can I do? Wait, unshare the screen, stop sharing. And then I take this one. Because I want to share to you guys the this one. The solution. Because I'm going to erase it from my screen. If I put here. Okay, dia ni tak apa. Internet saya pun tak apa-apa okay ni. My internet also not okay. I don't know why. Okay. And then the SNR at the output. Okay, this one SNR at the output. I give you the solution. I know. I give you the final answer. You try it. If you think that you cannot, we discuss in the next class. SNR at the output is equals to 46.95 decibel. Okay. Okay, try this. Okay. Try this at home. Okay. We will discuss in the next slide if you don't get it. Okay. If you don't get the value. Okay. Just close the screen. Discard. Okay. So that's it. Okay. The next class we will the next class we will continue on the slide number 45. Then we will finish noise in the next class. Then also we'll start with chapter 2, amplitude modulation. Okay. So for the students, okay, you can do test question. You can do test question, test 1, question 1. And test 2, question 2. Okay. Test 1, you can do question 1 and question 2 lah. Okay. Have you get this question before? I mean, do you guys get it already or not? The test question. Okay, I think you get it right. Last time I shared this one. This one. You get this one? This question. I think I shared last time. Okay. So okay. So you do practice at home because this test question is challenging. Okay.